Welcome guys, welcome to Maths and Science Masters. Today we are going to look at chemistry, right? So in this video guys, you can just pause it and rewind and make sure that you watch everything. Make sure that you understand everything, because I'm going to say something that will take more than 2 weeks lesson, or maybe more than a month lessons, right, to cover what I'm going to cover today. So if you make sure that you understand it, then you have done a huge favor to yourself, right? Make sure that you understand everything. So today we are going to deal with chemistry, masses and the moles, right? So those are the quantitative aspects of matter, right? We're going to deal with quantitative aspects of matter. This video is a fundamental video, in fact, because if you understand everything that we're going to say here, you are going to succeed in physical science, right? Physical science is no longer going to be difficult for you, right? So this thing that I'm going to do, guys, it covers a lot of topics, right? It will cover acid and base, rates of reaction, and also rates of reaction, and also chemical equilibrium, right? So those things will be covered by this small lesson that I'm going to do, right? So it might be an hour or more, but it is going to cover a lot, right? So the first thing is going to be, let's just name it. Let's say we are doing the stoichiometric, right? Stoichiometric calculations, right? Calculations. So if you understand them, guys, calculations, okay, calculations. So if you understand this, guys, we are going to do very well in our physical science, right? If you understand everything that we're going to do here, we're going to do a lot better in physical science, right? More especially in chemistry. So the first thing that we need to understand is the mole, right? Mole concept, right? Mole concept. What is a mole? This is the first thing that we are going to do. I'll also give an exercise that you are going to do, and then you will just pause, and then after pausing, then you can start doing I will do the corrections after in the same in this video also, right? Okay, so what is a mole, guys? A mole is something that chemists have come up with so that they can easily calculate a lot of things, right? Like for an example, they can calculate the mass of something if you are given the moles. But what is a mole? Mole is something that the SI unit of mole is going to be mole, right? This is the SI unit of mole, right? Is the amount of molecules. It is coming from molecules, right? So if you have got 1 mole of something, right? If you have got 1 mole of, let's say, 1 mole of H2O, 1 mole of H2O. If you have got 1 mole of H2O, what does this mean? It means that we have got how many molecules? Let me show you something, right? It means that we've got something called Avogadro's number, right? We've got something called Avogadro's number. Where is it? Here is the Avogadro's number, right? Avogadro's number, you can see, is Na here, right? Is Na here. Here is our Avogadro's number, right? Our Avogadro's number. It means that we have got if we have got 1 mole of H2O, 1 mole is equivalent to 6,02 multiplied by 10 to the power of 23 molecules. We use that because we cannot be calculating molecules one by one, because like for an example, in a glass of water we have got trillions of water molecules, right? Water molecule is H2O. I'm sure we're all familiar with that, right? That is where we started our chemistry, right? Understand that water molecules is H2O, right? It means that in each water molecules we have got 2 hydrogens and 1 oxygen atoms, right? So that is another thing that we need to understand, right? So if you've got 1 mole of H2O and they ask us how many molecules of water do we have in 1 mole of H2O, it means that we have got 1 multiplied by 6,02 multiplied by 10 to the power of 23, 10 to the power of 23 molecules, right? Molecules, right? So it means that it's going to be what? It's going to be 6,02 multiplied by 10 to the power of 23 molecules, right? So this is the amount of molecules, right? Molecules. So I wrote moles instead of molecules. Okay, so in this case, another example I'll give you. If you have got 0,25 mole of carbon dioxide, CO2, right? If you have got 0,25 mole of CO2, and then they ask us how many molecules do we have here, how many molecules do we have in 0,25 mole of CO2, it means that's going to be 0,25 multiply by the Avogadro's number, which is 6,02, multiply by 10 to the power of 23. All right, so what is the answer? I will just use my calculator for this one. So with the calculator, I'm just going to multiply the two things. So it's 0,0,25 multiplied by 6,02 multiplied by 10 to the power of 23. Multiplied by 10 to the power of 23. So it's 1,505. 1,505. So I will write it to two decimal place. Multiplied by 10 to the power of 23 molecules. Right? Yes, can be molecules of CO2. Right? It can be molecules of or particles, right? Or also particles. If we're talking about particles, it will be particles, right? So this is the amount of molecules or particles of CO2 in 0,25 mole of CO2, right? So now they might also ask us how many oxygen atoms are there in 0,25 mole of CO2. How many oxygen atoms? So for an example, because it's CO2, remember in each CO2 we have got two oxygen atoms, right? So it means that because we have got this amount of CO2, it means that the amount of O2 that is there is going to be 2 times this. So it's going to be 0,25 multiplied by 6,02 multiplied by 10 to the power of 23. And because we're talking about oxygen atoms, and then in each CO2 we've got 2 oxygen atoms, so that is why we're going to multiply it by 2. So it's going to be what? It's going to be okay, so let's just multiply it by 2. So if we just multiply it by 2, it's going to be what? If we just multiply it by 2, it's going to be if we just multiply it by 2, it's going to be 3,01 molecules, right? 3,01 molecules, 3,01 atoms, right? Sorry, 3,01 multiplied by 10 to the power of 23 oxygen atoms, right? Oxygen atoms. So that is the amount of oxygen atoms, right? So that is the first thing that we need to understand, right? So now I'm going to teach you how to calculate the number of moles given mass and how to calculate mass given the number of moles, right? So to calculate that, guys, we will use the formula N equals to m over m. This is the formula for us to calculate the number of moles. Like for an example, let's say we're given 10 grams of H2O. So if you want to measure what is the amount of molecules we have in 10 grams of H2O, of pure H2O, it means that we are going to say N is equal N of H2O. So we should put, or what is the N of, right? N of H2O is going to be given mass over the molar mass, right? As the small letter m is the given mass, and then the capital letter M is the molar mass. Where do we find the molar mass? The molar mass, we are going to find it in the periodic table, right? The molar mass, we are going to find it in the periodic table. So where is our periodic table? Here is our periodic table, right? Here is our periodic table. So what is the mass of oxygen? What is the mass of oxygen? So where is oxygen? Here is oxygen, right? Here is the oxygen, and then the molar mass is the bigger number that is below there, right? The molar mass is the bigger number that is below the atom there, right? So it means that is going to be what? The number of moles is going to be the mass that we're given was 10 gram over the molar mass. This is how we calculate the molar mass. Because we've got 2 hydrogens in each molecule, and then the mass of hydrogen is 16, right? Or is 1, sorry, is 1, and the mass of oxygen is 16. So it's going to be 1 because the mass of hydrogen is 1 multiplied by 2 plus the mass of oxygen, which is going to be 16, and we've got only 1 oxygen, so it's going to be like this. So it's going to be 10 over 18, right? So you can just punch into the calculator. 10 over 18 is what? 10 divided by 18 is going to be 0,555, right? So it's going to be 0,56 mole, right? So this is the amount of molecules of H2O molecules in the 10 gram of H2O, right? So that is the amount of H2O in the 10 gram of H2O, right? So now again, let's look at another thing. The next thing is when we are given the number of moles and they want us to calculate the molar mass, or they want us to calculate the number of moles, right? So it means that we are going to say what? We are going to say let's say we've got 0.35 mole, 0.35 mole of CO2, carbon dioxide, right? Let's say we've got 0.35 mole of carbon dioxide, and then they want us to find the mass of carbon dioxide, right? So it means that we're going to use the same thing. N of CO2 equals to M over cap M. All right, so what is the N of CO2? Is 0.35 equals to what is the mass? The mass is the one that we are looking for. And then what is the molar mass of CO2? Remember, carbon is what? Here is carbon. Carbon have got the mass of 12 and then oxygen of 16, right? So we've got one carbon, so it's going to be 12 plus the mass of oxygen is 16, and then we've got two of them, right? So it means that we are just going to have what? 0.35, and then this is the same as over 1, right? Because I want to cross multiply, right? Over M over this one is going to be 32, is going to be 44, right? And then when we cross multiply, it means that our M is going to be what? It's going to be 0.35 multiplied by 44. 0.35 multiplied by 44. So it means that it's going to be 15.4 grams of 15.4 grams of CO2, right? 15.4 grams of CO2. So that is how we're going to measure this one, right? That is how we're going to find the mass if we are given the molar mass. If we're given the number of moles, sorry, this is how we're going to find the mass if we're given the number of moles, right? So that is how we measure these things. This is the very basics of what we're going to do today, right? This is the basic of what we're going to do today, right? So now I'm going to talk about the reaction of hydrogen and water, of hydrogen and oxygen, right? Let's say hydrogen is reacting with oxygen, so hydrogen is going to be gas, and then oxygen, O2, is also gas, to form as H2O, which is going to be a liquid. All right, so if we've got this reaction, guys, it means that we have to balance our reaction, right? We have to balance our reaction. So when we balance our reaction, it means that I'm going to have a 2 here, and then after that I'm going to have what? I'm going to have 1 on what? Okay, the oxygen is now balanced, and then OH is not balanced now. So this is the balanced chemical equation of hydrogen molecule and oxygen molecule to form water, right? So there is our balanced reaction. All right, so what does this mean, guys? It means that this water molecule here, let me show you the water molecule, right? The water molecule is made of 1 oxygen and 2 hydrogens, right? 1 oxygen and 2 hydrogens. So let's say this one, for this thing, I'm going to name it, this is going to be our oxygen. All right, and then the red is going to be our what? The red is going to be our hydrogen, right? Hydrogen. All right, so let's say we've got a specific amount of hydrogen and specific amount of oxygen, right? Let's say I've got how many oxygen? Let's say I've got 6 oxygen atoms, right? 6 oxygen atoms. So it's 1 2 3 4 5 6 oxygen atoms, and then it is reacting with what? It is reacting with let's say 9 hydrogen atoms, right? So these are the things that are going to react, right? Those are the things that are going to react, right? Those are the things that are going to react. So after this reaction here, we are going to have what? We are going to have water molecules, obvious, right? We are going to have water molecule, right? And then remember, 1 oxygen should bond with 2 hydrogen atoms, right? 1 oxygen should bond with 2 hydrogen atoms. So let me just say we have got 10 of them. Let's say we've got 10 of them. Yes, okay, 1 oxygen molecule is going to bond with 2 hydrogen molecule, right? So it means that we're going to have a bond like this one, right? It means that we're going to have something like this one here. It's going to have something like this one. Remember, this one, it has to be what? 1 oxygen should have 2 hydrogen, right? Should bond with 2 hydrogen like that, right? So let me show you. So how many oxygen do we have? I've got 5 oxygens. There are 6 oxygens. It's going to be 1, 2, 3, 4, 5, 6 oxygens, right? So now let's bond them with our hydrogens. So this one will have 2 hydrogens, and then this one will have 2 hydrogens, and then this one will have 2 hydrogens, and then this one will have 2 hydrogens. So how many hydrogens have we used? 1, 2, 3, 4, 5, 6, 7, 8 out of 10, right? So it means that this one also will have 2 hydrogens. And then what about this one here? This one will not have hydrogen, so it will remain on its own. It doesn't have a friend to bond with, right? It doesn't have a friend to bond with. So it means that if we had these amounts, it means that this amount here, all the hydrogen will have something to bond with, but one oxygen atom will not have a hydrogen to bond with, right? So it means that we had an excess amount of oxygen in our reaction. So it means that that excess amount of oxygen, the excess one, is not going to bond with anything. So it will be just an spectator, to just be looking at others bonding, and then it will not have a friend to bond with, right? So it means that that is our limiting reagent, right? This is our excess reagent. It is excess on our reactants, so we call it an excess reagent. So because all the hydrogen found the oxygen to bond with, they were the limiting reagent. They are the one who is limiting this one to find a partner, right? Because they were few, right? We call them a limiting reagent. So this one will just stay there, it's into our reaction vessel, but not react with anything. We call it an excess reagent, right? We call it an excess reagent. So let's say we had this H2 and oxygen, right? Let's say we had a mass of 0,7. Let's say we had 0,7 grams of let's say we've got 0,7 grams of hydrogen, 0,7 grams of hydrogen, right? 0,7 grams of hydrogen and 10 grams of oxygen, right? 10 grams of oxygen. All right, and then they ask us what is the limiting reagent and excess reagent, right? So most of learners, when I ask them this kind of question, straight away they will say, no, we've got few hydrogen because we've got 0,7 gram, which means that our hydrogen is our limiting reagent. That is very wrong, right? That is very wrong. We firstly need to talk about number of moles. That's when we can talk about the excess and limiting reagent. We talk about the number of moles. That is when we talk about our excess and limiting reagent, right? That is very, very, very important, right? In order for us to talk about limiting and excess reagent, we must talk about the number of moles, not the masses, right? Not the masses, the number of moles. That is very important for us to understand, right? So it means that for us to be able to identify the limiting reagent here, we are going to do our calculations, and then we have to talk about them in ratio way. Okay, let me also include the ratio. It means that the ratios here, you can see that this one is balanced by 2. This one, obviously, because it doesn't have a coefficient, it's balanced by 1, and then this one, it is balanced by 2, right? So it means that the number of moles of oxygen, it is going to be half the amount of number of moles of this one, right? And then this one, the number of moles of hydrogen is going to be the same as the number of moles of H2O, right? After the amount that is going to react and the product that is going to be formed, right? So that is where we start, right? Okay, first of all, I'm going to calculate the number of moles, right? I'm going to calculate the number of moles. So for an example, if I find that here the number of moles is 0,1 and then here is 0,3, right? What I'm going to say is that, okay, this one here is going to be I'm going to check which one is the limiting reagent. So obviously, because I've got 0,3 and 0,1, some of you will jump into conclusion and say, no, this one is an excess reagent. Nope, we don't go there, right? We don't go there. We firstly check the balancing, right? Remember, this one should have been half. So if this one was 0,1 and then this one was going to be 0,2, right? Because this one has to be half, right? So if this one is 0,1 and this one is 0,2, it means that they will all react because this one is half of this one, and then the ratios there tells us that this one should be 2 times bigger than this one, right? So that is where we're going, right? So first of all, we will find the number of moles. then we can talk about the ratios, right? First of all, we'll find the available number of moles, then we can go to our ratios, right? So let's find the number of moles of let's find the number of moles of each, right? So n of hydrogen of H2 is going to be what? Remember, is m over cap m, right? So given mass of hydrogen is 0.7, and then the molar mass of hydrogen, remember the molar mass of hydrogen is the first one here, is 1, right? So how many hydrogens? We've got 2 of them because of the H2, right? So it's going to be 1 by 2, right? So this one's going to be 0.35 mole. All right, this one's going to be 0.35 mole, and then we check the number of O2, the number of moles of O2. So what is the number of moles of O2? The number of moles of O2 will be m over cap m. All right, so the given mass there is 10 grams over the molar mass of oxygen is 16, right? The molar mass of oxygen here is 16, right? So it's going to be 16, and then we've got 2 oxygen atoms, right? We've got 2 oxygen atoms. So what is the answer here? It's going to be 10 divided by 16 by 2. So it's 10 divided by 32, right? 10 divided by 32. So the answer is 0.3125. 0.3125. So this is the amount of oxygen that we have, right? So some of you again will come here and say, okay, straight away, this is our limiting reagent, right? This is our limiting reagent. So let me show you why we don't have to conclude that already, right? We don't just come here and jump into conclusion. Okay, if this one is the limiting reagent, right, it means that it's going to react, all of it is going to react, right? So it means that's going to be 0.3125, right? 3125. And then what will be the this amount of oxygen will react with what amount of hydrogen? Remember, the amount of hydrogen should be 2 times, so it needs to react with 3,125 by 2, 3,125 by 2, 0.3125, sorry, 0.3125 by 2. So it means that is going to be by 2, sorry, by 2, by 2. It means that it's going to it is supposed to react with 0.625, right? And then 625, do we have 0.625 amount of hydrogen? Nope, we only have 0.35 amount of hydrogen. So it means that the limiting reagent is going to be this one, because it doesn't have the amount that we needed there, right? So it means that this is the limiting reagent, right? So if they ask us about the limiting reagent, we'll know that the limiting reagent is going to be what? Is going to be H2, right? H2 is going to be our limiting reagent, right? Because we need 0.625 molecules to react with 0.3125 molecules of O2, right? So the limiting reagent is going to be our hydrogen, right? The limiting reagent is going to be our hydrogen. So once the limiting reagent is hydrogen, it means that we know the amount of hydrogen, all of it is going to be used up, right? All the amount of hydrogen is going to be used up. So I will remove this one because this is not correct, right? So the amount of hydrogen that is going to react is going to be the whole thing, right? The whole amount of hydrogen is going to react. So what is the amount of hydrogen? Is 0.35. So 0.35 grams or moles of hydrogen, right? 0.35 moles of hydrogen is going to react, right? So it means that now we can talk about the ratios. Now we can talk about the ratios. So because this one is 2 and this one is 1, it means that this 2 here has to be 2 times bigger than that one, right? So it means that here the amount that is going to react is going to be 0.35 divided by 2 mole, right? So what is 0.35 divided by 2? It's going to be 0.175, I think. Okay, let me just confirm with the calculator. 0.35 divided by 2, so it's going to be 0.175. yes, 0.175 mole. So it's going to be this amount that is going to react with this amount that is going to react, and then the amount of H2O, because it's 2, is the same as this 2. So here the amount of H2O that is going to be formed also is going to be 0.35 mole, right? That is how we do this one, right? That is how we do this one. So now we know the number of moles of H2O that is going to be formed, and then we know the number of moles of oxygen that is going to react, and we know the number of moles of hydrogen that is going to react, right? So now if the H2 is the limiting reagent, it means that O2 is our excess reagent, right? O2 is our excess reagent. So excess reagent is O2, right? Our excess reagent is O2, right? So once the excess reagent is O2, I'm just gonna rub here. Once the excess reagent is O2, it means that we can find the amount of oxygen that is going to be left, right? We can find the amount of oxygen that is going to be left. So what is the amount of oxygen that is going to be left? We know that is going to be oxygen, and that is going to be left unreacted, N of unreacted, right? Left is going to be the one that is not reacted. Unreacted is going to be N initial minus N reacted, right? So it means that the number of moles that didn't react, remember the limiting reagent doesn't have number of moles that didn't react. Only the only the excess reagent will have the number of moles that didn't react. So the number of moles that didn't react, remember initially we had 0,3125 of O2. So it's 0,3125, and then the amount that reacted is only 0,175, right? 0,175. So what is the amount of molecules that is left? So we know that the amount of molecules that is left is going to be 0,3125 minus 0,175. So it means that the amount that is not reacted is 0,1375 mole, right? So those are the amount that didn't react, right? Those are the amount that didn't, that is the amount that didn't react, right? That is the amount that didn't react. So once we have got the amount that didn't react, it means that we can talk about the mass that did not react, right? We can talk about the mass that did not react, right? So what is the mass that didn't react? So the mass that didn't react, so we know that N is equals to what? N is equals to M over cap M, right? So the amount that didn't react is going to be this one. So it's going to be 0,1375 equals to, what is the mass? The mass is going to be the one that we are looking for, and then the molar mass of unreacted, which is O2, is going to be the mass of oxygen is 16 multiplied by 2. So it's going to be what? It's going to be M equals to 0,1375 multiplied by 16 by 2 is 32. All right, so let's check the answer. So it's going to be multiplied by 32, right? Multiplied by 32. So it's going to be 4,4 grams. So 4,4 grams of what? 4,4 grams of oxygen did not react, right? 4,4 grams of oxygen did not react. All right, so if they ask us about the amount of O2 that is produced, there are two ways of finding it, right? There are two ways of finding the amount of oxygen or H2O that is going to be produced, right? So we can use again, because we know the number of moles of oxygen this one is unreacted, right? So let me put it a line here. So this one we're looking for unreacted, right? Unreacted. This one we're talking about unreacted. So of the product, now let's talk about the number of moles of product. So because we know the number of moles of product, it means that we know that we had what? We had 0,35 mole, right? We had 0,35 moles. So we know that N is equals to so is the product, remember, is H2O, right? It's H2O. So it's going to be M over cap M. All right, so it means that we know that the product I've got 0,35 mole. So 0,35 equals to, what is the mass? Mass is the one that we are looking for, and the molar mass of H2O is 1 multiplied by 2, because mass of hydrogen is 1 multiplied by 2, plus the mass of oxygen, which is 16. Right, so it means that is going to be M equals to 0,35 multiplied by this here is 18. right, multiplied by 18. So what is 0.35 multiplied by 18? 0.35 multiplied by 18. So it means that we are going to have 6.3 grams of H2O, right? This is going to be 6.3 grams of H2O is going to be produced, right? 6.3 grams of H2O is going to be produced. All right, so the other way we could have found this one, guys, is because we can use the what do we call this? We can use the we can use the conservation of mass, right? Law of conservation of mass on a chemical reaction. The mass of the initial product, initial initial reactants should be equal to the mass of everything that will be left still in the in everything, right? So because we know that we had this mass that is not reacted, it means that we had what? It means that we should, if we add everything, should give us back here, right? So we know that mass of product equals to mass of what? Equals to mass of reactants minus mass of what? Minus mass of unreacted. All right, so the mass of product, the mass of reactants, the other one was 10, the other one was 0.7, minus the mass of unreacted. So unreacted is 4.4, it's going to be 4.4. So the answer here should be 6.3, right? The answer should be 6.3, the same as this one, right? So we could have also find the mass of product in that fashion, right? We say the mass of initial products is fine, and then subtract the mass of the unreacted, and then it should give us the mass of the whole thing, right? The mass of the product, right? So that is how we can find this one, right? Now this is very, very important, guys. If you watch this video, if you don't understand it, you can watch it over and over again, because it's very, very important, right? It is very, very important. So I've produced a question for you guys that I feel like if you understand it, then everything is going to be much easier for us, right? Everything is going to be much easier for us. So this question, I'm going to paste it here, so you will take a break and then you will try it on your own, and then if you succeed with this question, it means that we did very well, right? It means that we did very well. So let me just put it on the down here. Let me just drag it down here. Let me just drag it down here. Let me just drag it down here. So here is the question, and then next the question, I'm going to put what? Below the question, I'm going to put this periodic table. I want you to use this periodic table, and then here is the periodic table, and then I will put also the formula sheet, right? I will also put the formula sheet because we are going to have it next to us, right? We're always going to have it, right? We're always going to have it. So here is the formula sheet and the periodic table. I hope you can just screenshot this and try to do it on your own, right? Try to do this question on your own. So the first question is stoichiometric questions formation of carbon monoxide, right? So they are saying consider the reaction between carbon and oxygen to form carbon monoxide. So there is the reaction, is already balanced, and we're given the mass of carbon is 25 gram and the mass of oxygen, which is 20 gram. And then they're saying define the term excess reagent and limiting reagent. Then the next question, they are saying calculate the number of moles of carbon and oxygen separately. And then they're saying between carbon and oxygen, which one is the limiting reagent. And then now they are saying determine the maximum mass of carbon monoxide that can be produced. And then they are saying calculate the mass of the excess reagent that will remain after the reaction. And after the reaction, it is found that the amount of CO2 obtained is 30 gram. Calculate the percentage of yield. So I didn't talk about percentage of yield, but I hope you understand the percentage of yield. So if you don't understand it, then you will see it on the corrections, right? So just give yourself how many minutes? Just give yourself 20 minutes to do this one, right? Just give yourself 20 minutes to do this one, and then we're going to come back with the solutions, right? I'm going to come back with the solutions.
Seven,
right? 27.27% is what? Is carbon, right? And then Now let's go to our solutions. So let's look at the first one. The first one is saying define the term excess reagent, right? So what is an excess reagent? We talked about that one, right? So the excess reagent is the reagent that will remain after the chemical reaction, right? Chemical reaction, that is our excess reagent, right? And then what is our limiting reagent? Limiting reagent is the reagent that will be used up in a chemical reaction, right? In a chemical reaction, right? So those are the two things that we need to remember, right? Limiting and excess reagent. And then with the stoichiometric calculations, we are going to focus on the limiting reagent, right? Because the excess reagent comes with something that we're not going to use on the reaction, right? You saw it, I gave you the structure, and I'm sure you understood it, right? Okay, so let's go to number two. Number two, they want us to do what? Number two, they ask us calculate the number of moles of carbon and oxygen respectively. Okay, so the amount of carbon, we know that we've got the mass. So if they ask us for number of moles of carbon, is going to be what? Remember, is mass over molar mass, right? So the mass is given of carbon is 25 gram over the molar mass of carbon, I think is 16. So the molar mass of carbon is 12. The molar mass of carbon is 12. It's going to be over 12, right? And then how many carbons? So it's just carbon as it is, right? So it's going to be what? It's going to be 25 over 12. So what is 25 over 12? So 25 over 12 is going to be 2,08, right? 2,08 mole, right? So that is the amount of carbon that we have, right? So now let's talk about the amount of oxygen. And of oxygen is going to be m over cap m, right? So what is the mass of the mass is going to be what? The mass is going to be 20 over the molar mass of oxygen is going to be what? The molar mass of oxygen is going to be 16, and then we've got two of them, right? So it's going to be what? It's going to be 20 over 16 by 2, which is going to be 0,625, right? So we've got the number of moles of both molecules, right? We've got the number of moles of both molecules, right? So now they want us to do what? They want us to find the determine the max, okay, between carbon and oxygen, which one is the limiting reagent. So we need to understand our limiting reagent. So that is number three. Number three, they want us to talk about the limiting reagent. So which one is the limiting reagent? Remember, we've got 2,8 moles of this one carbon, and then because it's 2,08, it means that this is 2 times. So here it has to be, if we need half here, half of this one is going to be 1,04. So we need, if the whole thing react, if this 2,08 react of 2,08 of carbon react, it will need to react with 1,04 of O2. So we have got only 0,625 of O2. So it means that the limiting reagent is going to be this one, right? So the limiting reagent, they ask between carbon and which one is the limiting reagent. So the limiting reagent is going to be what? The limiting reagent is going to be O2, right? It's going to be O2, because if the whole carbon reacts, it will need to react with the 1,04 moles of O2, and available we have got 0,625. So our O2 is our limiting reagent, right? So let's go to number 4. Number 4, they want us to determine the maximum mass of carbon monoxide that is going to be formed. So this one here, we will need to apply our stoichiometric calculations, because we know that this one is going to react all of it. So we know that N of O is going to be what? N of O is going to be 0,6 what? 0,625 mole. All right. So it means that N of carbon is going to be what? N of carbon is going to be 0,625 multiplied by 2, right? So what is 0,625 multiplied by 2? 0,625 multiplied by 2 is going to be 1,25 mole. So this is the number of moles of carbon that is going to react, right? The number of moles of carbon that is going to react, the number of moles of oxygen that is going to react, and then N of CO, carbon monoxide, right? Number of moles of carbon monoxide. You can see that carbon monoxide is balanced by 2. We've got 2 here, so it means that is the same as the one for carbon. All right, so it means that is the same, so it's going to be 1,25 mole of CO, right? So we know the number of moles of CO that can the maximum number of moles of CO that can be formed, right? So because they said what they want, the maximum amount of the maximum mass, so they want the maximum mass, so we know that N of CO is going to be M over cap M. All right, so what is the number of moles is 1,25, and then what is the mass? The mass is the one that we are going to look for, and then the molar mass of carbon monoxide is the carbon is 12 plus monoxide is oxygen, one oxygen, which is 16, so this is 28, right? So it's going to be M is equals to 1,25 multiplied by 28, right? 1,25 multiplied by 28, 1,25 multiplied by 28, so it's going to be 35, so it's going to be 35 grams. So that is the amount of carbon monoxide that is going to be formed, right? It's going to be 35 grams, right? It's going to be 35 grams. So this is the amount of carbon monoxide that is going to be formed. So now let's go to number 5. Let's go to number 5. Number 5, they are saying calculate the mass of the excess reagent that will remain after the reaction. So after the reaction, we know that on the excess, we know that we had this one, so the N remaining or N unreacted, right? N unreacted, N of unreacted is equals to N initial minus N final, right? So it means that N that didn't react, okay, N initial we had 2,0, or N reacted, sorry, N reacted, sorry, not N final, right? N unreacted equals to N initial minus N reacted, so it was 2,08 minus the one that is reacted. The one that is reacted for carbon is going to be what? It's going to be 1,25, so minus 1,25. So what is the answer? It's 2,08 minus 1,25. So the answer is 0,83. Answer is 0,83 mole. All right, so that is the amount of molecule that didn't react. All right, that is the amount of molecules that didn't react. So they're saying they want the mass, right? So if they want the mass, we know that N is going to be M over cap M. All right, so then reaction is 0,83, and then the mass is the one that we are looking for, and then the molar mass is going to be what? The molar mass is going to be the molar mass of carbon is 12, right? It's going to be 12, so M is going to be 0,83 multiplied by 12, right? So 0,83 multiplied by 12, so it's going to be what? It's going to be multiplied by 12, it's going to be 9,96. It's going to be 9,96 gram. So this is the amount of this is the amount of what? This is the amount of what do we call this? This is the amount of carbon that didn't react, right? Because our excess reagent was carbon, right? So the amount of carbon that did not react is this one. All right, so now let's quickly go to number 6. Number 6, what are they looking for? They are saying after the reaction, it is found that the amount of carbon monoxide obtained is 30 gram. Calculate the percentage of yield. Okay guys, the percentage of yield. Okay, so because it's a bit of a statement, let me write it down here, right? Percentage of yield, this is number 6, right? Percentage yield equals to actual or experimental, right? Or experimental yield over theoretical yield, right? So what we did in the calculations is a is a theoretical, right? What you calculated and found is experimental, right? So what is an actual yield? So the actual yield is going to be what? The actual yield is going to be the actual that we got in the experiment. They said after the experiment they got 35 gram, right? So it's going to be 35 gram over theoretical yield. So it's 30, sorry, it's 30. They said they got 30 gram, that is actual, or what we got through the experiment, right? And then but what we got on the calculation, we were supposed to get a 35, right? So it's going to be over 35 multiplied by 100. So what is 30 over 35 multiplied by 100? 30 divided by 35 over 100. So it's going to be 85.71%. 85.71%. 85.71%. That is how we calculate the percentage of yield, right? So that's it, guys. This is what I had for you in this lesson. I hope this helps you guys. Make sure if there is one thing that we did here that you don't understand, you are in trouble, right? I'm not playing. If there is one thing that we did in this class that you don't understand, you are in trouble, right? So stay tuned. I'm going to post another video about we'll be talking about volumes going to the concentrations and everything, right? But everything will be building up from here, right? The next aspect is going to be volume, and then we'll talk about the percentage of purities and everything. But now I want you to understand the mole concept, what we did here, right? This is our mole concept. If you understand this one, then you are in a good position. Thank you.
I'm good.
Hello,
How are you?
I'm good in you.
I'm also good. From Mr. Michigan's class for just these 2 days. How do you feel? Like, did it help you or anything like that?
Okay, I feel like Mr. Mutige's class were really helpful to us, especially during this time of exam season. I think that, it is very nice for him to come here and help us with the topics that we are struggling on. And it was really helpful for me. I got to understand things a little bit more better, and you see, so I really appreciate it.
Okay, would you rate him out of a 10?
Okay, maybe a 9.5 because
Alright, I understand. Come here.
Squared equals to VI